when we look at every function defined by a polynomial, as long as it's not a constant, as long as I have a variable, there is at least one complex zero, okay, which means I can have imaginary roots. So if we can't find all the real roots, what's left are imaginary ones. There will always be roots equal to the degree of the polynomial. And that's what the number of zeros says. The degree of the polynomial has at most however many roots is equal to the degree. So if I have a 5th degree polynomial, I have to have 5 roots. Now notice it says at most so many distinct. That means that I can have duplicates. Alright? I may have the same root show up more than one time. The same zero show up more than once. But it still counts towards the total. If I have a 6th degree polynomial, I can't have 7 zeros. There's too many. I can have 6. Or I can have 4 with some repetition to get up to 6. Okay? So that's what our theorems are looking at. Now what we're going to do is we're going to go backwards. We were given an equation. We wanted to find the zeros. Now we're going to give the zeros and we're going to write the equations. Okay? So what I want you to do is think back to when we found our zeros. If I have 0, -2 equals -2, x equals 1, and x equals 0. If I found my zeros, what did I do to work backwards to get my factors? Set them to 0. How do I do that? How do I do that for x equals -2?
Just put the 2 on those.
Okay, so what's it going to be? X plus 2. So we group everything to one side using our inverse operation. So I get x plus 2. Well, there's one of my factors. Okay, what about for x equals 1? X minus 1. There's another factor. And x is already set equal to 0. So there's a third factor. If I have 3 factors, what degree is my polynomial going to be? X to the third. Okay, so I'm going to have a 3rd degree polynomial. So now that I have my factors, all I'm going to do is take them and I'm going to expand it. I'm going to go ahead and multiply. Distributive property. X times x. Keep going. I'm going to do that one last.
And then 2x and 2.
Let's combine like terms. And then we'll distribute the last x in. Okay? So what am I going to end up with? There you go. So that's my polynomial that has zeros of -2, 1, and 0. Alright? Go ahead and try the next one on your own. Oh, yeah. Yep. Yep. Same way. Rinse and repeat. All right, what are my 3 factors? Good. Okay, if I multiply x plus 1 and x minus 2, what do I get? If I multiply x plus 1 times x
minus x minus 2.
Okay? And then if I multiply those, what's my final polynomial? That looks about right. Looks familiar. Disagreement about those signs? I think the numbers are good. Yeah, that should be good. All right. Last thing I want to talk about. Complex zeros. Okay? Because not all of our zeros are real. Sometimes we have complex ones. So, the thing with complex zeros is they always come in pairs. There's one, there's another. If there's three, there's four. If there's five, there's six. They always come in pairs. And so, the trick is to remember that they never give you both of them. They'll only give you one. So you have to remember that they have a conjugate that's going to be its buddy and always count as one of your roots. Okay? You'll have a plus version, you'll have a minus version. Okay? So I want to find a polynomial function, again, of least possible degree with coefficient, or only real coefficient, zeros of -2 and 3 plus 4i. What's the conjugate of 3 plus 4i? 3 minus 4i. So 3 minus 4i is also one of our zeros. It's implied just by the existence of 3 plus 4i. So what degree is this polynomial going to be? Okay, because I have 3 zeros again. So it's going to be to the third power. Okay, so I have x equals -2 as one of my zeros. I have x equals 3 plus 4i as one of my zeros. And x equals 3 minus 4i as one of my zeros. I want to do the same thing of getting everything from one side onto one side of the equal sign. So the x plus 2, that one's easy. Okay? Same process, just an extra step. I want to subtract 3 and subtract 4i from both sides. X minus 3 minus 4i. So it's just a little bit longer because we have that complex term, but the process is still the same. That's one of my factors. I want to subtract 3 and add 4i to both sides. X minus 3 plus 4i. That's my third factor. So now I have all three factors. The multiplication for this is going to be a little bit longer because now two of our factors have 3 terms in them. Always multiply the complex factors first because that's going to get rid of the imaginary unit. That's going to get rid of the I. You want that gone sooner rather than later. So while it's longer, do it first. It's going to save you a lot of headache. X minus 3 minus 4i times x minus 3 plus 4i. And then we'll also multiply by the x plus 2 when we're done, but that'll be after we clean up the first two factors. So do it with me. Okay? 3x plus 4xi. Okay? Now we're going to the second set. So we'll do -3 times x. Okay? I'm going to group it just vertically here, just to make it a little bit easier. What am I doing now? Here. Plus 9. Plus 9, so there's a constant. -3 times 4i. -12i. Okay, now we're doing the last one. Okay, so -4i times x. -4xi. What's going to happen with those two? So that's going to go away, which is good. That's what we want. I don't want complex numbers anymore. -4i times -3. Positive 12i. Hey, look. That cancels out as well. And then the last one, -4i times 4i. Okay, what's special about I squared? It's -1. Okay, so I get from there -16i squared which equals negative 16 times negative 1, which just gives me a positive 16. And now I just combine my like terms. X squared minus 6x plus 25. And then, don't forget the x plus 2 from our other factor, and then we'll just distribute one more time. The third, 2x squared, negative 6x squared, negative 12x, 5x, plus 50, and then combine like terms. Minus 4x squared, plus 13x, plus 50. So again, we ended up with a third degree polynomial. We knew that would happen because of the number of zeros. Make sure you multiply, get rid of those complex numbers first. Other than having to remember the existence of a conjugate, the process is the same. Okay? Take your zeros, write them as factors, and then expand it out. Questions, comments, concerns, queries, or conundrums? Cool. You got your assignment. Covers yesterday and today. Have fun.